the binomial distribution. And so it's a very specific, it's a discrete distribution. That's why it's in this section. Okay. And it involves trials. Okay. I think your book probably goes over this probably even better than me. But it involves trials with kind of a pass-fail scenario. Some books call it pass-fail, but you'll see what I'm talking about when we get there. But it's going to involve trials, and in each trial, you're going to have a probability of passing or failing that's consistent for every trial. So if we look at, I'll give you an example that I can think of off the top of my head. So if we know that to roll a die, to land on any of the numbers is 1/6, right? You got a 1/6 chance of rolling any number. That means you have a 5/6 chance of not rolling the number, right? So you have the pass-fail probability. And if I want to know, well, what's the probability if I roll a dice or a die, 10 times? That's my trials. What's the probability I roll a 3 4 times? Well, so you've got the number of trials, the number of times you're going to have success, and the number of times you're going to have failure. Okay, so that's the way this distribution's set up. You got the total number of trials, and then you've got the probability of success or failure for each trial, each what is it? Yeah, for each trial, yeah. And your book really does a better example. It says, this is on the top of page 269. There's a fixed number of trials. There are 2 possible outcomes for each trial, success and failure. The probability of success is the same on every trial. The trials are independent. So that means that the outcome of one trial does not affect the other, right? If we're rolling a die, the first time you roll the die does not affect the second time you roll the die. The trial, and then the random variable x represents the number of successes that occur. So let's write that down. X equals number of successes. Okay, x equals the number of successes. What you got? It takes a minute before it gets into the actual formula here. Or am I just skipping over the formula? I don't see it in the book. Oh yeah, there it is. It's on the bottom of page 270. That's the formula. So it looks like this, and I'm going to do an example and kind of plug in the numbers to the formula. That's kind of the easiest way to do it. So the probability of X number of successes, so that's what we're looking at. The probability of X number of successes is going to be N, remember, okay, N is the number of trials. Let's write this down. N is the number of trials. In composed, or not composed, but in combination X. And then P is the probability of success. Let's write that up here somewhere. P equals probability of success. So P raised to the X power, and then 1 minus P raised to the N minus X. Now these are being multiplied. There's 3 things being multiplied here. So you've got the combination, which we learned about in the last section, right? The combination of the number of trials and the number of successes times the probability raised to the number of successes times 1 minus, so the complement, right? 1 minus P, so times the complement of really raised to the losses, N minus X. So let's look at this. I'm going to make up an example that I hope kind of makes sense here. Let's say, let's do one with kind of an easy. Actually, you know what? I'm going to steal the example on page 271. The Pew Research Center recently reported that approximately 30% of internet users in the U.S. use the image sharing website Pinterest. So suppose a simple random sample of 15 internet users is taken. Use the binomial probability to find the following probabilities, and we'll do A. A is find the probability that exactly 4 of the sampled people use Pinterest. So now let's look at this. says, really, we're going to define success as someone using Pinterest, right? So success, the probability of success is 0.30 because it says about 30% of internet users use Pinterest. And then it says a random sample of 15 internet users is taken. Well, that's our number of trials. So n equals 15, okay?
Okay.
And then for part A, it has find the probability that exactly 4 of the sample people use Pinterest. So really what that is that's the number of successes, right? For part A, it wants to know what's the probability we choose exactly 4 people that use Pinterest. So I'm going to go through this equation. So if n is 15, so n combination 4, we'll put that in the calculator, times, now we've got the probability of success was 0.30, and that's going to occur 4 times, times the probability of failure, right? 1 minus p. Well, 1 minus p, the probability of failure is 0.70, right? And that's raised to n minus x. Well, if we've got 4 that are successes out of 15, that means 11 are going to be failures. That's n minus x. Okay? Then I'm going to go to my calculator. I'm going to put that in just like that. So I'm going to say, okay, Texas Instruments, try not to get a glare in here. Clear. I got to remember where these are. I think it was stat calc. Nope, that's not it. It was math. Yeah, math probability. N choose R. Now it's 15 and 4. So 15, enter. Oh, shoot. I should have hit over. So I'll do 15, math, probability. So it puts it in there for me already. 4, and let me go to the right out of that, times 0.30 raised to the, was it 4? Yeah. And then 0.70 raised to the 11. So it looks just like that. So notice this looks the exact same. There's that glare there. Looks the exact same in my calculator as it does on this equation. And we get back 0.2. I'm going to round to 4 decimal places. Or I guess 3. Your book does 3. 0.219. 0.219. Okay. 0.219. So this, now look, this is what's important though, interpreting this. So there is a 0.219 probability that exactly 4 out of 15 users are on Pinterest, given there is a 0.30 probability of a single person being on Pinterest. Now really, yeah. So there's a 0.219 probability that exactly 4 out of 15 users are on Pinterest, given there is a 0.30 probability of a single user being on it, right? If we knew that about 30% of people were on Pinterest, then if we sampled 15, 4 of them would have a probability. There would be a probability of 0.219 for 4 being on there. Okay. Does that make a little sense? Okay, let's go on. So now let's go to part B here. Part B says we'll find the probability that fewer than 3 of the people are on Pinterest. I really, and if I kind of draw it like this would be probability that, it's less than 3. So fewer than 3 would be on. So same example. We've got 15. I'm going to kind of write this over here. We got 15 trials. We know the probability of success is 0.30, right? That hasn't changed. But now what's the probability that less than 3 are on there? So really what this means is we need to add the probability that none are on Pinterest plus the probability 1 is on Pinterest plus the probability 2 is on Pinterest. Of course, we wouldn't add 3 in there because it's got to be less than 3, not less than or equal to 3. So we have to do each one of these now. For less than, you have to do each one of these. So we would do, okay, so this the probability x is less than 3. So the probability for 0, if we wrote it out with that equation, would be 15 combination 0. Now 0.3, there would be no successes, right? So you'd have 0.3 to the 0 times every single one of these would be failures. So 0.7 raised to the 15. This is the probability that none, like we sampled 15 people. Turns out not a single one of them is on Pinterest. That's what this probability is going to pop out. We'll get each one of them as we go. Plus, now let's do the probability of 1. So it would be 15 with 1 success. Now that would be 0.3 to the 1, right? Times 0.7 to the 14, right? Because 1 would be a success, but 14 would be failure. And then lastly, 2. So we'd have 15 combination 2, 0.3 to the second power, and then 0.7 to the 13th power, right? Because 13 out of the 15 are failures. So I'm going to do each one of those. So I'm going to go back. I'm going to be a little lazy. If you hit second enter, you can like go back and change this. So I want 15 combination 0 times, well, this would be raised to the 0. And this would be raised to the 15 now, though, right? That's that first one. So 15 to 0, 3 to the 0, or 0.3 to the 0. 0.004. So 0.00, I'm going to do 4 decimals for this one, 4, 7. So look, very slim chance that we have exactly no internet users on Pinterest, right? 0.0041, less than 0.5%, right? Okay, what about exactly 1? So second enter brings it right back up. I'm going to change that to 14. This to 1, and that to 1. So the probability we have exactly 1 out of 15 is 0.0305. So that's this middle one right here. So exactly 1 would be 0.0305. Now what about 2? So I'm going to do the same thing, second enter. This would be 13. This would be 2. And that would be 2. Almost 10%. 0.0916 if I rounded, right? 0.0916. Now I'm going to add these together. And we get 0.127. So the probability that if we polled 15 internet users, that less than 3, so 0, 1, or 2, use Pinterest would be 0.127. Okay? 0.127. Questions, Lori?
No, I'm just figuring it out here on my calculator.
Well, I'm going to show you.
So I know.
Yeah, no, I understand. And I'm going to show you a quicker way on the calculator to do this. The combination or this binomial stuff's built into the calculator. And I want to do these examples by hand, and then I was going to do them kind of shorthand. So don't worry too much if you're struggling with this part of the calculation. It's one of those things where if I don't show you the hard way, the math gods come down and they get upset. Okay, so what about part C? Part C, now remember, we're still up here. 15 trials, 0.30% of success, right? That we choose someone that's uses Pinterest. C says find the probability that more than one person uses Pinterest, not interest. The probability that more than one person uses Pinterest. Well, so that would be X is greater than, wait, is it more than? Hold on.
Greater than.
Yeah, more than
It's
one.
greater than.
Yeah, it's got to be greater than, right?
Greater than, more than, same thing.
Same thing, yeah. And I'll tell you, the long way to do this, which we're not going to do, remember there's 15 of these people. So technically this, you would have to add, more than one would start at 2, right?
Right.
2 plus 3 plus 4 plus 5 plus ... 6, 7, 8, 9, 10, 11, 12, 13, 14, right? Plus all the way up to 15. I don't have enough time in this lecture to do all that. So we're going to use the conjugate aspect of this, right? We know that the probability of X greater than 1 plus the probability of X really less than or equal to 1, right, is equal to 1, because this is everything, right? X can either be greater than 1 or it can be less than or equal to 1. So if we want to know this probability, all we have to do is subtract the probability that X is less than or equal to 1 to the other side. So it turns out the probability of X greater than 1 is equal to 1 minus the probability that X is less than or equal to 1. What's nice is we've already got this up here. I didn't realize I could kind of cheat on this one. Not cheat. Use the previous one. Now, this is going to be much easier to solve for. So the probability that X is greater than 1, which seems like it would be a really high probability, right? I mean, if we know, if we've got 15 people and we ask every single one of them, do you use Pinterest? And we know the success is 30%. The probability that, 2, exactly 3, exactly 4, like all those added up are going to be pretty high. So to do the math on this one, though, this would be 1 minus. Now, the probability X is less than or equal to 1, that would be the probability of 0 plus the probability of 1. Right? The probability that X is less than or equal to 0. We just have to add up 0 and 1. And we know that from up here. Right?
Okay.
The probability of exactly 0 is 0.0047. The probability of exactly 1 is 0.0305. So X is greater than 1 would be 1 minus, I'm going to add those together, 0.0047 plus 0.0305. I'm just going to do this all at once. 1 minus parentheses 0.0047 plus 0.0305. And I get 0.965 if I rounded. 0.965 if I round. Okay.
Okay.
Now, I'm not going to do D. I want you to do D, and that's fine. I'm going to go on to actually showing you the easier way to do this in your calculator, so you don't have to now, I'll tell you it's not that much easier, but it's a one-step thing, so you don't have to put it all in at once. And I'm going to go back to that part A, and I'm just going to do it in the calculator. Part A was we've got 15 trials. We know the success is 0.30. And for 15, we wanted to know, or for part A, I'm sorry, on 271, we want to know what's the probability we have exactly 4 successes. So is the probability that we have exactly 4 successes. Okay, so the way you do this, I'll try to write this underneath here as I'm going along. You have to use the distribution function in your calculator, which if you look at this calculator, you'll see in the blue right here, or that second, it says DISTR, that's distribution. So you've got to hit second.
Okay, right on bars.
Bars, exactly.
Yeah.
Second bars.
Second bars.
And then you've got to scroll down for a little bit. And eventually, second verse, you're going to see Binomial PDF. For me, it's option A.
Yeah, mine too.
You've got to scroll down for a little bit, but you'll see.
You can scroll up too when it gets on there.
Say it again.
You can scroll up once you get on there too. It goes both ways.
Okay. And now click on it. Now I'll tell you, for the old calculators, if you've got an 83, you've got to put these in sequentially. But on the newer calculators, it asks you what to put in. So if you click on it, and I already did this one earlier just to make sure I knew what I was doing, but you'll see it asks for trials. So we're going to put 15 because we're asking 15 people. The probability of success is 0.30. And we want to know what's the X value of 4, right? When we have 4 successes. Now, if you got the older calculator, you need to put in, when you clicked on Binomial PDF, I'll show you what it'll say. It'll put that in first, and then you put 15 comma, actually write that in, 15 comma 0.30 comma 4. So it's number of trials, probability of success, and what probability of success are you looking for? We want 4 successes. And if you hit enter, you'll see you get, I'm just gonna put follow directions here. Follow directions. But when you do that, you're going to get a Binomial PDF. There's a CDF. It means something different. We'll go over that here in a second. But Binomial PDF, 15, because that's the number of trials. Next is your probability of success. We know it was 0.30. And then what's the probability you're looking for? Well, we're looking for 4 successes. So this winds up being 0.218. If you
actually 0.219 rounded off.
9, yeah, it's supposed to be rounded up, isn't it? 0.219. So it does it automatically in calculator, which is nice. So we don't have to go through the each one of those per se. Okay. So kind of neat. And I'll do this again just to kind of give us a few examples of it as we go along. But it is nice. It's nice using the calculator for this section. And you'll see the book like starts off using tables. Whew, let's not go over that. Okay, we're just going to use the calculator here. Hold on. Let's think of another example here. Let's say, hold on, I'll Google something real fast. A little theoretical in a way, but let's look up free throw percentage. Let's look up Shaq's.
Also on page 275, it shows how to do the whole formula for using it in the calculator.
Yes, which is nice. And we'll go over the CDF here in a minute. Okay, so let me write this down here. Shaq's free throw percentage for his career is 0.527. Now it's 52.7, but we need it written as a probability. Okay, so 0.527 is his career free throw percentage. Okay, so let's say there's a single game. In a game, Shaq shoots, let's say we did 10 effort. Let's say 12 free throws. Okay. In a single game, Shaq shoots 12 free throws. Okay. And for part A, I want to know what's the probability he makes exactly, let's say half. Exactly. Well, yeah, let's say half. Exactly 6 free throws. Okay, exactly 6 free throws. So now this isn't like he makes, 6, 7, 8, 9, 10, 11, 12. No, this is exactly 6. He makes exactly 6 free throws. So now let's think about what we have. We know the trials are 12, right? We know the probability of success for Shaq is going to be 0.527, right? And for this example, my X is going to be 6. So I'm going to pop that in the calculator. So I've got 12 trials this time. 0.527 is my probability of success. And then I want to know what about exactly 6? Okay. What about exactly 6? Now I get 0.222, right? If you round it to, so the probability of, not X, but we want to know the probability of 6, right? Would be 0.222. Okay. So there's a 22.2% chance he makes exactly 6 of his free throws. Okay. Now I'm going to change it up a little bit. I gotta get some more paper. So what if, so same thing, we know he shoots 12 one night, 12 free throws. We know his probability of success is 0.527. That's not going to change, okay? Because it's a single night. We know he's got 12. What's the probability he makes at least, let's say at least 3 free throws, okay? He makes at least 3 of them, right? So, I mean, he's going to make 3, 4, 5, 6, 7, 8, 9, 10, 12, right? At least 3. So if we think about this, we want to know what's the probability that X is greater than or equal to 3 here, right? He can make 3, he can make 4, he can make 5, right? Now we have to think of this as the complement. Making at least 3 would be 1 minus the probability of less than 3, right? Those would be the same exact thing. So I've got to think, so really what we're going to do, 1 minus the probability that he makes none, plus the probability he makes 1, and the probability he makes 2, right? Because that would be the probability X is less than 3. Now, this is when we're going to use the CDF, okay? The CDF. Yeah. So let's go over that just a little bit. So if you look in that the options when you go to VAR, second distribution, and you scroll down, you're going to see Binomial Cdf. And what Binomial Cdf is it I'm trying to think what the C has to be. It has to be kind of addition or computing up. But the CDF means that we're adding up to a number. Okay. Your book says to compute the probability that of less than or equal to X, select CDF and enter the values for N, P, and X separated by commas. Okay, so for us, we need to think of for this one, now this would be for this calculation, okay? Not the 1 minus, but that calculation right there, 0, 1, 2. If we would do Binomial CDF, we know the trials are still 12, right? The probability of success is 0.527, but see how we're adding 0, 1, 2? The C adds this up sequentially, 0, 1, 2, and you're going to use the biggest number there on where it stops, okay, 2. And what this does, the CDF adds up 0, 1, and 2 automatically, okay? It adds it up automatically. So if we go back, so I've got to go to second distribution, down to the CDF, 15 trials, right? My probability of success is 0.527, but now the X value is going to be 2 because it's adding up 0, 1, and 2.
Is it 15 or 12?
Oh, you're right, 12. Because he shoots 12 times, right?
Yeah.
And I get 0.0120. Yeah.
Yep.
So that's the probability for 0, 1, and 2 added together. So if I wanted the probability that X is greater than or equal to 3, it's just 1 minus that, 0.01207. So 1 minus that winds up being 0.9879 if we rounded to 4 decimal places, okay? 0.9879 is the probability. And that kind of makes sense. I mean, think about this. If he takes 12 free throws, the probability he makes at least 3 of them is going to be very, 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 very high, right? The probability he makes at least 3 free throws is very high. Okay.
Okay, how did did you do that in the calculator again? Somebody was making noise over here.
Which part?
To get to the 0.9879.
Oh, did you get the 0.0120?
Yeah.
Well, if you do 1 minus answer and you hit second enter, it'll bring up the answer. So 1 minus and then hit second enter. Oh, I'm sorry, second minus sign. 1 minus and then second minus the negative sign down here. So all that does is it brings up 1 minus your previous answer.
Oh, okay, cool.
It's kind of neat. So if you like calculated something and you need to do something to it, you can bring it up with the answer key. Okay, so let's say, and this is just because I'm really interested now. What's the probability? He makes no free throws. Out of 12. Okay, so he winds up shooting 12 times and he misses every single time. It's going to be a very, very small probability, right? He's got a 50-50 chance of making one of them, right? It's going to be a very slim probability he misses all of them. So really now we're back to just a single probability, right? We just want to know none. So it's going to be, it's not CDF because we're not adding it up. It's Binomial Cdf. Right? He's going to shoot 12 times. His probability is 0.257, but then now it's 0 for success. Okay? So I'm going to go into my calculator, second vars, all the way down to Binomial Cdf. 12 trials, 0.527. X value would be 0 here, right? Because there's no successes. Oh yeah, it gives mine in scientific form 1.25. Yeah. Now what that means is it's 1.254 times 10 to the negative 4 power, right? So if I need to write this as a decimal, or if it's like a multiple choice and I got to figure out which one is right, we got to move this decimal 4 times to the left, right? So 0.0001, 1, 2, 3, 4, 254. Okay.
Okay.
So that would be, so look, he's going to make at least one shot. I mean, he might not, but it's a point. Really, if you think of this in percentage, it's 0.01% of the time he would, if he took 12 shots, he's not going to make a single one of them. Okay.
Okay.
Okay. Cool. So we've got that down. We know how to put in the calculator. We know how to do it by hand even. Let's talk about the mean for these and the standard deviation. The mean's actually very easy to calculate, and it kind of makes sense. So this is on the top of page 275, but for binomial distributions, the mean, which, we can write it as that, or we even talked about now, you can write it as expected value, right? Either one of those is fine. You just multiply n times p, and it kind of makes sense. Like if we know, remember in the last example, we had Shaq. He shot the ball 12 times. That was n. The probability he succeeded was 0.527. So his expected value, the expected number of times if he shot it 12 times, you just multiply those together. Now, in reality, he can never get that amount, right? Because it's going to be a decimal. But that would be his expected amount. So it's 6. Oh, wait. Let's do it for Shaq. For Shaq, the expected value would be, 12 times 0.527, so 6.324, okay? The mean for this distribution with 12 trials and the success is 0.527, the expected value would be 6.324, which kind of makes sense. I mean, it's about half, right? And you shoot it 12 times. It's about 6. Standard deviation is a little weirder to find. The standard deviation for the number of successes, you do the square root, and you make sure all the stuff's underneath the square root. N times P times the conjugate, 1 minus P, okay? N times P times the conjugate of 1 minus P. So for this example, it would be the square root. Now, N was 12, right? So N times 0.527 times 1 minus 0.527, whatever that winds up being. I'm just going to pop this in my calculator. Just make sure everything's under the radical when you do this, okay? And I get 1.72, we'll say 95, so I don't have to round it, okay? 1.7295. That's what I got. Yeah, and we're not going to talk much about the mean and the standard deviation for this. We're going to talk about that later, actually, in chapter 7, but it will be on the test. How to calculate it will be on the test, okay? But the interpreting really isn't a chapter 6 topic, okay? You'll see chapter 7 and really chapter 8 is all interpretation. So we'll look more at interpretation later on in chapter 7 and chapter 6. I'm sorry, chapter 7, chapter 8. But for now, it's just knowing how to do the, punch the buttons in the calculator, okay?
Okay.
Knowing that. Questions? Lori, Coulter, you guys got any questions?
I believe so.
Okay.
That's pretty easy to me.
It feels pretty. It is. I mean, I feel like overall, it's not the hardest concept we're going to go over this semester. And then you'll see 6.3 or 4 that we'll do tomorrow is similar in nature, where it's just a special discrete distribution. Let's just pull an example out of the book and do it in the homework. Let's look at. Let's do something not as sad.
Not as sad.
And some of these get kind of gloomy. Like, I'm trying to do an even one. That way you guys have the answers for it.
So we have the answers for it?
I have the answers for the odds.
The odds are in the back of the book, yeah.
Yeah. I was going to choose an even one. So you had the answer.
Okay.
Let's see here. Let's look at number 34. It talks about, I think, cell phone towers, maybe something like that. So 34 on page 277 says, a study conducted by Pew Research Center reported that 58% of cell phone owners use their phones inside a store for guidance on purchasing decisions. I did that this weekend at Lowe's because the price of vacuums is ridiculous, in my opinion. And I had to get on the internet, which I couldn't get on it in the vacuum section. But when I walked outside, I got on because, dear Lord, I didn't realize how expensive they were going to be.
Oh, yeah.
Yeah. And so a sample of 15 cell phone towers is studied. Okay, so let's think about this. We know, I'm assuming success. What is the probability that 6 or more of them use their phones for guidance on purchasing? Okay. 58% of cell phone users use their phones. Sample of 15. Okay, yeah. So we've got, N is going to be 15 here, right? Because we've got 15 users that are going to be sampled. And then success is going to be 0.58. That's not going to change, right, at all. But let's look at A. What is the probability that 6 or more of them use their cell phones for guidance? I'm definitely going to use that CDF function here. Because what's the probability of 6 or more? So that means X is greater than or equal to 6, right? That's what we want to know. 6 or more. You got to be very careful on how you come up with this part. 6 or more. So remember that CDF function in your calculator, it adds up from 0. So it doesn't do like 6, 7, 8, 9, 10, 11, 12. It would do, but it could add up 0 to 5. So that's what we have to think of this as. Remember, this is 1 minus the probability that X is less than 6, right? The complement aspect of this. And look, that CDF function, we can do X is less than 6 because really it's 1 minus the probability X is less than or equal to 5. Those mean the same thing, right? And this is going to be, and I'm going to write it exactly how it would in the calculator, which we'll use the function. But this is going to be Binomial Cdf. Now the trials are 15, success is 0.58, and then we're going to add up to 5, right? 0, 1, 2, 3, 4, 5. So 1 minus, so I'm going to take the calculator out. And I'm going to do just that. So second distribution, scroll down or up to CDF. I've got 15 trials, 0.58% of success, and I'm going to add up to 5. So it looks something like that. Hit enter, and you wind up with
0.48.
Yeah, let's do 4 decimal places.
Okay.
0.04. We'll round at the very end for whatever they want us to round it to. They do want us to round it to. It looks like 4 decimal places. So 0.0479. And then 1 minus that is going to be 0.9521. So that's the answer to A, okay? So the probability that X is greater than or equal to 6. So we get, the probability if we sample 15, exactly 6, exactly 7, exactly 8, exactly 9, all the way up to 15, say that they use this in the store is 0.9521. Ugh, I don't know what's so hard to say. Now B says, what is the probability that fewer than 10 of them use their cell phone for guidance? Fewer than 10. Would that include 10? No, I don't think so. I feel like 10 or fewer would include 10, right? But fewer than 10 would be the probability X is less than 10. Well, what's nice about X is less than 10, that's the same as the probability is X is less than or equal to 9. And that's kind of how we need to think of it in the calculator. This is just that binomial CDF. $15 trials, 0.58. But now we're going to add up 0 to 9. Okay? There we go. And I get 0.6570 if we do 4 decimal places. Okay. 0.6570. So it's kind of nice when it's a less than because it's kind of really built into the calculator already. Okay. It's kind of built into the calculator already. And then part C says, what is the probability that exactly 8 of them use their phones for guidance? So now instead of a less than or greater than, it's just 8. So instead of CDF, now we're going to switch it over to PDF, right? So it's going to be binomial PDF because that's an exact. And we know we've got 15, 0.58 is success, and we want to know 8 here. So second distribution, if I go up, oh yeah, it's quicker if you go up, isn't it, Lori?
Mm-hmm.
Yeah, we have 15 trials, 0.58, and we want to know exactly 8. So it looks like that. And you get 0.189998. Now your book does want you to round to 4 decimal places. So this is actually going to be 0.1900 if you rounded to 4 decimal places. 1900. Okay. Questions?
Yeah, I already forgot on doing the second one minus second answer.
Yeah.
I don't know if my calculator's messing up on me, but
Well, I'll tell you,
coming up error.
I wouldn't worry. When are you talking about for up here for part A?
Yeah, for part A to get to the 0.9521.
Well, I would just do one. Did you get this number right? 0.0479?
Yeah.
I would just do 1 minus that then, and don't worry about it, Lori.
Okay.
So you don't have to worry about it. I mean, that way you don't mess up that way. Just put it in by hand.
Okay. Okay. Yeah, I think that'll be easier.
Yes, it will be.
I know I've been trying to do some homework in my calculus class, and some reason it's going to something else than what I'm looking for.
Yes, that's always fun, right?
Yeah, especially when if you hit second, I guess twice, it's going to go to whatever the other thing is.
Yes.
It's like,
Right.
drove me nuts.
Let's look at part D now. It's kind of interesting. It says, would it be unusual if more than 12 of them had used their phones for guidance on purchasing? So would it be unusual more than 12? So really 13, 14, right? Let's look at the probability of more than 12. So that's X is greater than 12, right? The probability that X is greater than 12. So 13, 14, 15, 13, 14, and 15, right? Because there's 15 total.
Mm-hmm.
Now remember, N is 15. Probability is 0.58, right? 0.58. Now, if we want to do this one, we are going to have to do the 1 minus again, right?
Mm-hmm.
This would be 1 minus the probability of X being less than or equal to 12. It would be the same as taking 1 and then subtracting off what isn't greater than 12, well, less than or equal. So this one, we are going to do 1 minus binomial. Now, this would be CDF, right? Because we're adding it together. We're adding 0 to 12 together. So 15, 0.58, and 12. I wonder if you could do that all together. Here, let's see. I want to see something real fast. Look, if I do 1 minus and then put this in there, it should do it. CDF. 15 trials, 0.58, 12. Yeah, see how it puts it all in on one line, which is kind of nice. So I did 1 minus. I did this exact thing in my calculator. And I get 0.0189. 0.0189. And I want to talk about this for a minute because it's going to be so important when we get to chapter 9. Look, this is very rare. Look, if we had 15 people on their phone, if we surveyed 15 people, and we know 58% use their phone to do this, and it says, what's the probability that we get more than 12, right? If it turns out that, if we got 13, 14, and 15, right? The probability that 13 out of 15 plus 14 out of 15 plus 15 out of 15, that's this number right here, right? The probability that they use their phone inside the store, that is such a small probability. And really, the book early on in this semester, the book kind of said, look, if it's less than 0.05, it's considered unusual. Okay, so I'm going to say yes, this is unusual. Because the probability is less than 0.05. And that's going to turn into a bigger concept coming up in a few lectures, okay? But it's considered unusual because the probability is less than.
I hate it when that happens.
I know. I'm trying to leave. Okay. Okay. So let me dig some homework out. You know, the homework for this book goes through the sections, and it starts on the top of page 270, and I definitely want you to start there. So page 270. This is section 6.2. One, and then 2 is on. Yeah.
2 is on 274.
Yeah, I want you to do 1 through. I want you to do 1 through 41 and just do the odds. I mean, it's about 20 questions. So 1 through 41 odd, and then make sure you know how to find these in the calculator. I'll tell you the hard part on these will be the like less than, greater than. Once you know the buttons to press, it'll be the less than, greater than, that kind of stuff. Winds up really messing with people, with students on how to calculate that kind of aspect of it.